Okay, third and final video for section 2.3, some of our application-based problems. So using the chain rule, it says find all the points on the graph of f of x, which is the cube root of x squared minus 1 squared, for which dy over dx equals 0 or dy over dx does not exist. So in order for us to figure out where the derivative is 0 or where the derivative doesn't exist, we need to find the derivative first. So the first thing I'm probably going to want to do is rewrite f of x. I want to write it as just a power instead of a root. So I'm going to rewrite that as x squared minus 1 to the 2/3 power. Remember, it's the power over root. Now I can go ahead and find the derivative. So if I want to figure out where the derivative is 0 or where it doesn't exist, I need to take the derivative. This is a chain rule. I've got the 2/3 power on the outside. X squared minus 1 is the composite piece. So we'll bring the 2/3 out to the front. Rewrite the inside. Multiply that by, excuse me, not multiply it by yet anything yet. I have to reduce the exponent by 1, which will be the negative 1/3 power. Then we multiply that by the derivative of the inside, or the composite function, which is 2x. Now, in order to tell where this thing equals 0, where it doesn't exist, I definitely want to clean this one up. Okay, I want to put this in the form that's going to make it easy. So the 2x has a positive exponent because there's really no exponent written there, so it's going to go on top of a fraction. The negative 1/3 power on the x squared minus 1 drops it to the bottom of a fraction, and it just so happens that we have a fraction 2/3, so the 2x gets multiplied on top, which is 4x. And the 3 is going to get multiplied by the x squared minus 1, because I drop that to the bottom now and make it a positive exponent. So now I have a fraction. This is my derivative. So what I really need to do now is figure out where does this thing equal 0 or where does it does not exist. Well, for a fraction to equal 0, the numerator must equal 0. So for the dy dx to equal 0, we're going to take the numerator and set it equal to 0. Fortunately, that one's pretty easy. X is 0. For the derivative to not exist, where the derivative does not exist is when the denominator equals 0. So we'll take the denominator and set it equal to 0. Some of you might be able to do this quicker than others, but if you were solving this, you would divide by 3. Okay, the 3 goes away. Then you're going to take and cube both sides. Well, cubing 0, just like dividing 0 by 3, is still 0 on the right side. So ultimately what I get is x squared minus 1 equals 0. And then you can either add 1 and take the square root on both sides, or you could factor that to x plus 1, x minus 1. One way or the other, you're going to get that x equals positive or negative 1. So that is where, or it says find all the points. So technically we should be finding actual points. So if I were to take 0 and plug it back in, because you need the y values that go with these. If I was to take 0 and plug it back in, I'm trying to find the y value. A y value is f of x, not the derivative. We plug it back into here. If I plug 0 in there, I'm going to get 0 minus 1 squared, which is 1. Cube root of 1 is still 1. So we get y equals 1, which means I have a point 0, 1. Then if I were to take positive or negative 1 and plug it back in here to the x squared, when I square it, it's going to give me 1. 1 minus 1 is 0. 0 squared is 0. The cube root of 0 is still 0. So both positive and negative 1 give you y equals 0, which means the points are 1, 0 and negative 1, 0. So these are the points where the derivative either equals 0 or does not exist. Okay. Okay, it might be presented in a slightly different way. Suppose, and that should probably look a little different than it does. That should look like u of v. Suppose that w equals u of v, which is another way of saying a composite function, u of v of x, basically. And they give us a whole bunch of values there of u and v and u primes and v primes and all kinds of stuff. Well, they want us to find W prime of 0. Okay, so the first thing I'm going to probably do, because I think it's easier to see this way, is I'm going to rewrite W as U of V of X. Now, there's really no X's here explicitly, but we can just assume maybe that it's some variable X. So it should be easier to see now. If I take the derivative, because to find W prime of 0, I need to find W prime of X first, basically. So if I'm going to find W prime of X, it's the derivative of the outside, which is U prime of the composite, times the derivative of the composite. Technically times the derivative of X, which is 1. But again, we don't need to write that part down. Now I want to find W prime of 0. Well, all that means is take 0 and replace it where the X's are. So it's U prime of V of 0 times V prime of 0. We can fill in some of the information. We know what V of 0 is. They gave that to us right there. V of 0 is 2. So I'm going to take U prime of 2 times V prime of 0. They gave that to us. That's 5 right there. And then we need to find U prime of 2, which is up here somewhere. Yep, is 4. So we get 4 times 5, or 20. That is W prime of 0. So we obviously didn't use all the information up on the top there, so that's good, because sometimes everybody thinks, oh, I have to use everything. Some of the cases you will, some of the cases you won't. Okay, moving on. Now we're given some information in a chart form, as opposed to just written out like it was last time. So what you can see in your chart is you've got X values, 1, 2, and 3. You've got a bunch of F of X, G of X, F prime, and G prime values in that chart. So you have to be able to read the chart as well as be able to do the calculus. First one says, if capital F of X is lowercase f of lowercase f of X, that's not weird or anything, find capital F prime of 2. So if I want to find capital F prime of 2, the first thing I need to find is capital F prime of X in general. Well, that is the derivative of the composite of little f of X. So it's the derivative of the outside piece, keep the composite, multiplied times the derivative of the composite. And now I want to find capital F prime of 2, which means replace 2 for all the x's. So F prime of F of 2 times F prime of 2. So let's see, what do we know? I know F prime of 2. Here's 2. I'm sorry, F of 2. Here's F of 2. That's 1. So I'm going to replace F of 2 with 1. F prime of 2. F prime of 2 is 5. And F prime of 1 is 4. So we get 4 times 5 equals 20. It's kind of funny. That was the last answer. But there you go. All right, let's try it again. We're going to do it with G this time. So capital G of X is lowercase g of X. We want to find G prime of 3. I hope this will not end up being 20. So let's take, in general, G prime, or capital G prime of X, which is lowercase g of X times lowercase g prime of X. Replace the x's with 3's. So G prime of G of 3 times G prime of 3. Let's go to our chart. G of 3. G of 3 is 2. So that goes there. So I'll need to take G prime of 2. G prime of 3. G prime of 3 is 9. And so I need G prime of 2. G prime of 2 is 7. So then we get 7 times 9, which thankfully is not 20, it is 63. So that is the derivative of capital G as it was defined. Next one's a little bit different. Same general idea, but you have to be really careful about what you're seeing in the chart. This time, g of x is, again, it's defined to be f of x. We want to use the table to estimate the value of g prime of 1. There's a very big key term in that sentence that we just read. It says estimate, meaning we will not be able to find the exact value of g prime of 1. We are going to do an estimate. And when you are asked to estimate the derivative, typically you are talking about some kind of an average derivative or average rate of change. Average rate of change meaning some kind of a slope, probably a y2 minus y1 over x2 minus x1. So let's see what we've got. In order to do it, we're still going to have to find g prime in general, which is going to be the derivative of f of x times the derivative of f of x. And if I want to find g prime of 1, we need to replace x's with 1's. So f prime of f of 1 times f prime of 1. Okay, it's important that we write this step because at least it tells us the pieces that we're going to need. Well, some of it I actually do know. So it wants us to find f of 1. So when x is 1, what's the value of f? Well, that's 2. So then it's f prime of 2 times f prime of 1. But there are no f primes given in that chart. So this is where the estimate comes in because it says we want to estimate this. Well, in order to estimate the slope at 1, the best thing to do is to take the values which are closest to 1 and average those. So I want to take the slope as close as I can get to x equals 1 as possible. Well, I've got these two values which I could use because 0.5 to 1 is only 0.5 away, but I've also got these two values which I could use, both of which give me x and y ordered pairs, so I can do y2 minus y1 over x2 minus x1 and find average slope. So let's figure out, first of all, this is going to be, because this one's surrounding x equals 1, so that's really going to be this piece right here. So let's see, we're going to do y2 minus y1 over x2 minus x1. And 2 minus 0.8 is 0.2 divided by 0.5. 0.2 over 0.5, you multiply top and the bottom by 10, you get 2/5. Okay, that's doing between there. But we can also do between here and then average the two values. So let's do that one as well. So we're going to get 2.4 minus 2, that's y2 minus y1 over 1.5 minus 1. So that's going to be 0.4 over 0.5, which is 4/5. Again, multiplying the top and the bottom of that by 10, you get 4/5. Then if I want to find the average between these two, I just add them up and divide by 2. 2/5 plus 4/5 is 6/5. Divided by 2 is 3/5. So this is a good estimate for f prime of 1. 3/5. And then we can do exactly the same thing, but at 2. So now again, we've got these values. Oops. I do, but it's not what I meant to circle. We've got these values and we've got these values, which are close to 2. So we're just going to do the same idea, but we're going to surround x equals 2. So we're going to have 3.1 minus 2.4 over 2 minus 1.5. So let's see, 3.1 minus 2.4 is 0.7 over 0.5, which is 7/5. And then we'll do the second one, which is 4.4 minus 3.1 over 2.5 minus 2. So 4.4 minus 3.1 is 1.3 over 0.5, which is 13/5. Adding those two things up, you get 20 over 5, which is, was that 4? So then we end up with 4 as a good average or estimate for f prime of 2. So then multiplying 4 times 3/5, we get 12/5. That is the approximate value of g prime of 1. Okay, kind of a long drawn out process there for that one, but that's a good way to do it. And understanding when they say estimate, it means you're probably going to have to do an average slope. And the best thing to do is to find the closest averages that you can to the specific slope that you're trying to find. And if you can surround them like what we did and then average the two, that's even better. All right, one more page. This one actually will not be that long. It just looks like it. Because r of x here is defined to be f of g of h of x. And you know what? I think I might have made some kind of a mistake. I could be wrong, but I think I made some kind of a mistake there. Maybe not. Oh, yes, I did. I did on the previous page, so I apologize. Let's go back down here real quick. I didn't average this thing right here. I actually just added the two up. It's really 7 plus 13, which is 20, divided by 2, because I want to average it, so it's really 10 over 5. This should be 2, not 4. So let's replace that. That makes much more sense. I knew something didn't seem right. That becomes 6/5. All right, hopefully you guys caught that before I did. All right, again. So last time, this last one, it's basically a triple composite. F of g of h of x. It's the same idea, though. If I want to find the derivative of r at 1, or r prime at 1, I need to find r prime of x. Just be careful. Start with the outside. It is f prime of everything else on the inside. G of h of x. Be careful that you got the right amount of parentheses. Okay, now we're done with the f. Times the derivative of g, which is g of h of x. Now we're done with the g, times the derivative of h, which is h prime of x. From here, it's just about plugging in the values. So it's r prime of 1, which is f prime of g of h of 1, times g prime of h of 1, times h prime of 1. So let's see, f prime of g of, what is h of 1? H of 1 is 2. Times g prime of h of 1. Once again, h of 1 is 2. Times h prime of 1, which is 4. Okay? F prime of g of 2. G of 2 is 3. Times g prime of 2, which is 5, times 4. And then f prime of 3, we actually used everything here. So it's 6 times 5 times 4. 6 times 5 is 30, times 4 is 120. And there you would have a triple composite. So biggest thing, again, is just being careful. All right, this has been quite a long lesson, but chain rule is one of the more challenging things typically for people to master, so you just need to practice. Take your time, really understand what's going on here, really understand composite functions. It's going to come back to us again in the future for sure. So make sure you really have this, but that is plenty enough for these videos.